All right, this is screencast number 3 for Unit 5, Lesson 3, and I'm on page 254. What causes tidal cycles? The rotation of the Earth and the Moon's revolution around the Earth determine when tides occur. Imagine the Earth rotated at the same speed that the Moon travels or revolves around the Earth. If that were true, the same side of Earth would always face the Moon, and high tides would always be at the same places. But the Moon revolves around the Earth much more slowly than the Earth rotates. A place on Earth that is facing the Moon takes 24 hours and about 50 minutes to rotate to face the Moon again. So the cycle of high tides and low tides, guys, so the Earth rotates once on its axis in 24 hours. But during that time, remember that the Moon is also moving in its orbit around the Earth. So to catch up with where the Moon is, you actually have to rotate through one complete rotation plus a little bit more to catch up with the Moon, which means it's not going to be the cycle of high and low tides aren't going to repeat itself every 24 hours, but it's going to take a little bit longer than 24 hours for that cycle to repeat itself because the Moon is moving in its orbit as we rotate as well. Okay. In many places, there are 2 high tides and 2 low tides each day. Because the tidal cycle occurs in 24 hours and 50-minute intervals, it takes about a fourth of that, 6 hours and 12 and a half minutes, for water in an area to go from high tide to low tide. It takes about half of the 24 hours and 50 minutes, okay, which half of the 24 hours and 50 minutes would be about 12 hours and 25 minutes, to go from one high tide to the next high tide, or to go from one low tide to the next low tide. Okay. Because if you'll think about it, if you can think about the fact that the Earth rotates once completely in 24 hours, and if we start on the side that's facing the Moon, well, when about 6 hours, a little over 6 hours has gone by, we've made a quarter of a turn, and now we're not facing the Moon. We're at a low tide. Okay, 6 more hours go by, and we're on the opposite side of the Moon. That's another high tide. Another a little more than 6 hours go by, and we're not lined up with the Moon again. That's a low tide. Okay, so just remember that it takes 24 hours and 50 minutes to complete the tidal cycle of 2 high tides and 2 low tides. Okay, and if you will keep that in mind, then you'll be able to fill in the tide data for Clearwater, Florida, the example that's down at number 12. Okay, so let me pause this for just a second and do a little bit of highlighting for you. All right, so I went back and I underlined where it says the rotation of Earth and the Moon's revolution around Earth determine when tides occur. A place on Earth that's facing the Moon takes 24 hours and 50 minutes to rotate to face the Moon again. So the cycle of high tides and low tides at that place happens 50 minutes later each day. It takes about 6 hours and 12 and a half minutes for water in an area to go from high tide to low tide. Okay, so let's look at the tide data for Clearwater, Florida. If you start out having a high tide at 12:14 a.m., then if you add 6 hours, 12 and a half minutes to that, what you're going to get is a low tide at 6:26 a.m. in the morning. Okay. From 6:26 a.m., if you add 6 hours and 12 and a half minutes, you wind up at 12:39 p.m. If you take 12:39 p.m. and add 6 hours, 12 and a half minutes, then you get 18, let's see, 39 plus 12. I can't think. Let's see. 39. I'm going to round that to 13 this time. Okay. 1852. Well, some of you guys aren't familiar with military time. 1852 is the same as me saying 6:52 p.m. Okay? All right. So each time I am adding 6 hours, 12 and a half minutes. 6 hours, 12 and a half minutes, 6 hours, 12 and a half minutes, 6:52 p.m. Okay? Then the next one occurs at 1:04 a.m. the next morning on August 20th. 7:17 a.m. Remember, you have to add 6 hours, 12 and a half minutes, to get your answer. 7 and 6 is 13. 12 and 17 is 29. Switch pins. Okay. 13:29 is the same as 1:29 p.m. So you'd have a high tide at 1:29 p.m. If you add 6 hours, 12 and a half minutes to that, you're going to get 7. Let's see, 29 plus 7:42 p.m. Okay? All right, so do you see how this works? So take 7:42 p.m. and add 6 hours and 12 minutes. The next one will, because it's 6 hours, 12 and a half minutes, the next one will do 6 hours, 13 minutes. So we'll just kind of alternate. So 7:42 p.m. plus that's going to put us to 1:58 a.m. on August 21st. Add 6 hours and 13 minutes to that. 13 and 58. 71, so that's 1 hour and 11 minutes. Okay, 11. That's going to be 8:11 a.m. Okay. Add 6 hours and 12 minutes. That's going to be 14:23. But that's the same as me saying 2:23 p.m. in the afternoon. If I add 6 hours and 13 minutes to that, 23 plus 13 is 36. 6 and 2 is 8. So you'll have another low tide at 8:36 p.m. Okay, but each time to go from high tide to low tide, you add 6 hours, 12 and a half minutes. To go from low tide to the next high tide, it's 6 hours, 12 and a half minutes. To go from high tide to low tide, 6 hours, 12 and a half minutes. Okay? So high, low, separated by about 6 hours, 12 and a half minutes.